Today we'll be continuing our study of vectors, and specifically we'll be moving on to some of the things we can do with vectors now that we understand what they are. So namely, we'll be moving on to adding and subtracting of vectors. So adding and subtracting of vectors is actually really useful because now we can take those scenarios that we were working with earlier and we can combine multiple steps in order to get a result. So this is the triangle law of addition. So essentially what this is, if we have a vector A and a vector B, or in this case, AB for vertices and BC, then when we add them, one of the ways we can graphically add them is we can put them tail to tip. So what that means is we start with the tail of our first vector, and then we go that to the tip of the arrow, and then we get the tail of our next vector, so the end bit, and then we put that to the head of that vector, and then we go all the way, and then we go from the tail of the beginning to the end, and this is our resultant vector AC. So this is a really easy way to add vectors, and this lets us do all sorts of things later on in given scenarios, such as someone walking in one direction and then walking in another direction, and we can find out where they are at the end, and it's just really useful. So moving on to some examples of how we do this. If we're given vectors v and w, we want to find v plus w and w plus v. So I'm going to do this roughly, but if we have v, then we're going to have v plus w. So we're going to start with the tail of v and go about here. And then we want to go tail to tip. So we take the tail of our next vector and add it to the tip of our first vector. And we're going to continue it up there. And that's going to be our w. And then the resultant vector is going to go from the tail of the first vector to the tip of the second vector. And that's going to be v plus w. And that's it. So that's the triangle law of addition. So we essentially just added these two vectors to find the result. Now, if we look at w plus v, what we're going to do is we're going to start with w. So we're going to start w going up here. And again, this is just rough, so it's not going to be exact. But then we're going to have v, and v is going to, the tail of v is going to go to the tip of w, and it's going to go back the opposite way, because that's what v does. And then it's v. And so what we're going to do is we're going to go to the bottom of w, and then that's going to go up to the top of v. So we put w plus v. So now we've added the two vectors this way. Now, if you look at these two vectors look very similar. In fact, they're the same vector, the two red vectors, the v plus w and the w plus v. It doesn't look perfect here, but that's just because it's a rough sketch. But essentially what's happening here is this is very much like the normal laws of addition that we've looked at previously. So if I had, for example, 5 plus 3, well, that's just going to be 8. And if I had 3 plus 5, 3 plus 5, well, that's also going to be 8. So just like with normal addition, vector addition, it doesn't depend on the order. So I can have one vector going first or another vector going first, but as long as I'm adding the same vectors, I'm going to get the same resulting vector. And this actually brings me on to the next way of adding vectors. Rather than just using triangular addition, we can use the parallelogram law of addition, which essentially uses this process. So instead of just making a triangle using the two vectors to add them, we actually make a whole parallelogram. And essentially what a parallelogram is, it's a four-sided shape where it has two pairs of parallel sides that are of equal length. So essentially this line, this vector and this vector are the same, and this vector and this vector are the same. So this becomes a parallelogram. So if you have so let's say that AB is equal to A and AD is equal to B, then what we're going to see here is that we have A here, and we're going to reflect it here, B here, and it's going to be the same here. So this is just another method of addition, and it gives you the same thing. So you can either just do half of this with the triangle law, and you get the same thing, or you can do it the other way. This is just an easier way of remembering that it doesn't matter what the order is. And because it doesn't matter what the order is, the parallelogram law is useful. We can actually do it. Otherwise, this vector coming from this side and this vector coming from this side would be different. So this is the parallelogram law of addition. We just make a parallelogram, essentially, with the vectors we've got. We put our first vector and repeat it, and then we have our second vectors joining those two. And that's it. And then we go from the side that has both tails to the side that has both tips, and that's our resulting vector. Generally speaking, though, you'll usually use the triangular law of addition. It's only in certain circumstances where you may have a parallelogram that you'll use something like this. Anyway, moving on to some more useful facts about vectors, or rather some examples about how to use that. We can take the given vectors v and w, and we want to find v plus w. So we have v and w, and if you look at this, they're actually making a vertex or a corner for a parallelogram. So rather than trying to move this down here and then figure it out, what we're going to do is we're just going to use these to make a parallelogram. So I'm going to, again, I want a parallelogram, so I want this vector to be the same as this vector. So I'm going to extend w out here. And then I'm going to take v, and it's going to continue in the same direction. It's going to be the same vector. And so that's going to be v. So then the resulting vector goes from the side that has the two tails to the side that has the two tips. And so it's going to go this way, because we've got our two tails here, our two tips here. This is going to be v plus w. And if they had asked for w plus v, it would be the exact same vector. So for this one, write the vector that represents p plus q in the diagram shown, as shown. So with this one, they've already given us the parallelogram, like I was saying. Sometimes they'll just give you a parallelogram and want you to work from there. And so from here, we go from the side that has the two tails to the side that has the two tips. So we put the tails with the other tail. We put our beginning tail with the other tails, and we put our tip with the other tips, and then we just connect the two, and that gives us our vector that we want. So this is going to be p plus q, and that is the same as q plus p, the exact same vector. It's just another way of representing it, but just like I was going over earlier, this parallelogram rule only works because this is true. So now moving on in vectors, we look at subtracting vectors using a triangle. So subtracting vectors works in a similar way to adding vectors and also subtracting real numbers. So when we're subtracting real numbers, let's say we had 5 minus 3, for example. That's going to be equal to 2. But another way you may have seen this written, and it's usually just so we can simplify it, is you can sometimes think of this as 5 plus minus 3. That's going to be exactly the same thing. But when we're talking about algebra, we normally don't write this because it's a more messy way of writing it. But it is the same thing. And that's important to note because it's really useful in vectors because we already know how to add vectors. But what we don't know how to do right now is subtract vectors. So essentially what this is doing, this is essentially giving us a way of subtracting vectors just using the same laws of addition that we already know. And so that's really apparent here. So if we have a minus b, this is the same as a plus a negative b. And we learned in the last video what a negative b does. It just changes the direction by 180 degrees, or another way of thinking of it is it just makes the vector point in the exact opposite direction with the same magnitude. So here we have a and we have b, so b is pointing this way. So if we wanted to subtract b, what we would do is we would find a negative b, so it's the same vector, different direction, or rather opposite direction, not just any different direction. And then we just add the 2. So we take out a vector and we add now our negative version, not our positive version, which would be going up here. And then from there, we just do the same rules, tail to tip. So we start at this tail and we go to that tip. And then that gives us a minus b. And that's exactly what we wanted. So when you're subtracting vectors, you can use the same triangular addition, but you have to use the negative version of the vector. And you have to be really careful about which one you're making negative and which direction the negative version should actually be pointing. So that's really something to pay attention to. Anyway, moving on, we can look at zero vectors. Now, a zero vector is, as the name suggests, it's the vector equivalent of the number 0. So if I draw, say, a coordinate system, and because this will make it a little bit easier, and I had, say, 1, 1, 2, then I can have a vector going from here to here. So that can be my vector A. I can have another vector going from here to here. So that can be my vector B. And I might even have a vector going just straight up, straight vertically. And I'll do this in a different color so it looks a bit different. And we might even have a vector going this way, and we can call that vector C. So it can go along the axis, and these are just different kinds of vectors. So why am I bringing this up? Because the zero vector is easiest to represent on a coordinate system. Because what a zero vector is, it's just a vector that you're going to be putting right in the middle. It's essentially just a point, and it's just the point at the center of wherever you're starting. So if you have a starting point, a zero vector will just be that single point and nothing else. And so this is pretty apparent when we're adding a vector to its negative, it gives the zero vector. That's pretty simple because if we look at regular numbers, if I take the algebraically, sorry, this is just not working yet. If I take algebraically the number 5 and I just subtract another 5, well then what am I going to get? I'm going to get 0. So it's the same thing with vectors. So if we look at this vector A, if we were to then subtract A from this, then we'd have negative A, which would be pointing in this direction. So if we then use our laws of addition that we've already learned, we go A, that's all nice, but then we go negative A directly backwards. So then that gives us just starting and ending at the same point. So if we want to draw an arrow from the starting and end point, we just end up with a single dot. And so that's the zero vector. It's just a single point starting and ending at 0. It's not generally a useful vector, but it's useful to know when it happens. So knowing that this occurs is really useful because we've essentially just shown that our normal rules involving algebra apply to vectors. And that's what this whole section's been about. It's been about showing that all the rules that we have for adding and subtracting numbers, they all apply to vectors, except we usually think about it graphically rather than using numbers, which is numerically. All right, so moving on. We want to subtract vectors using triangles. So now we're just going to go through some examples of how to actually subtract some vectors. So given vectors v and w, we want to find v minus w. So we have our vector v. So this is our vector v. But then if we want to subtract w, we want to use the negative version of w. So that's going to be going this way. So what we're going to be doing is we're going to then be adding that. So again, tail to tip. So this is negative w. So then our resultant vector is going to go from the tip of this one to the tail of this one. So then we're going to end up with v minus w. And looking at this example now, we can do the exact same thing, except the only difference is now we're going to be working with a negative v, not a negative w. So we'll start with our normal w, and so that will be over here. So this is A, this is B. So we have our normal w, but then using negative v, we see that actually goes down and to the left. So using that, we're going to go down and to the left, v, negative v. And so the resulting vector, w minus v, that's going to be from this tail to this tip. And so we're going to end up with a vector that looks something like this. I'll just fix that up so it doesn't look like 2 v's. So this is essentially how we subtract vectors using triangles. And if you wanted to go on and then use the parallelogram rule, it's the exact same thing that we were doing with adding vectors, except now we're working with the negative versions. So it's not too bad to make the change. It's just flip it first and make it negative, and then you just do all the same rules we did with parallelogram, or the parallelogram law of addition, and it changes in the same way that the triangle law of addition changed. Anyway, I hope that was helpful, and I hope you guys watch the next video.